Okay, quadrilaterals are going to be done the exact same way as triangles and the other ones. We just have to define our variables and then find out some sort of relationship. The first problem here says you have a rectangle. The sides of the rectangles have length x plus 5 and width 2x minus 3. And it tells you the perimeter, the distance all the way around is 48. So a couple of different ways you can work this. And some of the people in class had really creative ways of doing this. So one way is you could do x plus 5 plus x plus 5 plus 2x minus 3 plus 2x minus 3 would equal the distance around, which is 48. That's one method. The method that I like is all the way around would be 48, but what if you only went halfway around? It'd be half of that 48, which is 24. So the cleaner one, let's do x plus 5 and 2x minus 3. If I just add up those two sides, it's going to give me 24 instead of 48. And you're going to get the same answer this way. Combine your like terms. That's going to be 3x. Let's move our 5 and our 3 to the other side by subtracting 5 and adding 3. And that's going to give me 22, I believe. When you divide by 3, that's going to give me an x value of 7.3 repeating. We'll just call it 7.33. So then you go back and plug it in. 7.33 plus 5 will give you 12.33. There's one side. 2 times 7.33 will be 14.66. Subtract 3, that's going to be 11.66. And you can add those four sides together, and it should give you that perimeter of 48. And from there, again, we can find all the different components of the rectangle. We can find area. We can find whatever I asked for. So the next one says the side of a square is twice a number, that's 2x, and then minus 3. So, and we know that all the sides of a square is the exact same thing. The area is 49. Now, let's talk about the easiest way of doing this. To find area of a square, you simply multiply length times width. So we've got to figure out what number times itself is 49, and that would be 7. So that tells us all the side lengths are 7. So the easy equation is, I know this side right here has got to be 7. And then you can just solve it from there. We can add 3, divide by 2, and that gives me that x has a value of 5. So the perimeter, it asks for the perimeter and different things. So if all the side lengths are 7, the easy way to find the perimeter would be 7 and 7 and 7 and 7, which would be 28. There's your perimeter. It says find all the characteristics of this square as well. So let me redraw it. Now that we know all the side lengths are 7, we do know what the x value is already. So if we know all side lengths are 7, if I were to draw this diagonal right here, well, I know that in a square, that's going to cut this angle in half, so both of those will be 45s. So that diagonal in a 45, 45, 90, the sides are the same, and to find the hypotenuse, you multiply by root 2. Okay, and then the other diagonal would be the exact same length of 7 root 2, if you want to find all the different components. Next up, the diagonals of a rhombus. Now, let me show you the easy way that I have for drawing a rhombus. I draw a stick, and then I cross it right in the middle. Okay, and then I draw the side lengths. So in a rhombus, all four side lengths are the same. Now, if you want to draw a kite, you wouldn't have to cross it in the middle. You could cross it above or below the middle. So the diagonals of a rhombus measure 2x plus 1 and 3x minus 5. The area is 60. If you don't remember how to find the area of a rhombus, area is equal to 1/2 d1 times d2. So if your two diagonals are here and here, let's plug that in. That gives me 60 equals 1/2 times 2x plus 1 times 3x minus 5. Now, this first step's a little tricky. What I do is I'd move that 1/2 over here. Since 1/2 is being multiplied, in order to move it over, you're going to divide by 1/2. From 4th grade, division by 1/2 is the exact same thing as flipping and multiplying. So to move that over, really, I just got to multiply by 2. So 120 is equal to 2x1 plus 1 times 3x minus 5. Now, we got to clean this thing up a little bit. I'm going to actually multiply these together. And if you don't remember how to multiply them, we're foiling. We're going to do 2x times both of these. That's going to be 6x squared. 2 times 3 is 6. X times x is x squared. 2x times negative 5 is a negative. 2 times 5 is 10. Leave the x alone. 1 times 3x is a positive 3x. 1 times negative 5 is negative 5. So now what you've got is actually a quadratic equation. We're going to combine all of our like terms. I'm leaving 6x squared over there. My negative 10 and plus 3x, I'm going to combine into negative 7x. My 120, I'm moving it over by subtracting 120 with the other side, and that's equal to 0. Now, we're going to use my method to actually solve this. Anytime the middle number is odd in my method, we double everything. So that's going to be a 12, a negative 14, and a negative 250. Left leg, right leg, opposite, and half. Would be the opposite would be positive, half would be 7, half of 14. Multiply that number times itself. To find the head, we're going to multiply these two numbers, and that gives me negative, I believe it would actually be 3,000. So final answer, left leg, plus and minus, the square root of the difference. So that's going to be the square root of 3,049. Now let me actually type that in. Let's see what the square root of 3,049 is. It's actually, and I'm going to go ahead and erase it, 55.22. And all divided by this number, 12. So again, the x values, you've got two different x values. I'm going to go ahead and put x equals. The negative, normally in geometry, we throw the negative away. But we're going to do 7 plus the 55.22. That's going to be 62.22 divided by 12. The 7 minus is going to be negative 48.22 divided by 12. So 62.22 divided by 12 gives you about 5.19. There's your first answer. And then negative 48.22 divided by 12 gives you a negative 4.01. And again, I'm not going to do it, but you could actually plug those in for your x's. And that's going to tell you the two different diagonal sizes. 2 times 5.19 plus 1. 3 times 5.19 minus 5, that's going to give you the length of those two diagonals. And like I said, the other one can be thrown out because once you plug it in, your diagonals can't be negative numbers. Now, you could go, again, I'm not going to, but you could go a step further with that and actually find all the angle measures and the side measures inside of that. All right, the last one. The diagonals of a kite, and again, use that same trick that I showed you to draw it. We're going to draw pretty much the letter T. And we're going to connect our corners. So there's the top of the kite. There's the bottom of the kite. Just a reminder that a kite's a lot like a rhombus, but it only has one line of symmetry. So the diagonals here have a ratio of 3 to 5. So different ways you can work this. I'm going to go with scale factors. If it has a ratio of 3 to 5, if you figure out what you can multiply one by to give you the other one. Like, how can you go from 3 to 5? What can you multiply by? The way you can find that is just by dividing those two numbers. I'm actually going to do it the other direction, though. I'm going to go from 5 to 3. I've got to figure out what do I multiply 5 by to give me 3. If you do 3 divided by 5, it gives you 0.6. That's your scale factor. So to go from the larger to the smaller, you're going to multiply by 0.6. That's one way of doing this. So if it gives you the shorter one, the only issue is it says the shorter diagonal is 9x minus 6. This would take you from the larger to the smaller. So to go backwards, you would actually, instead of multiplying, you're going to divide by 0.6. So I'm going to take 9x minus 6, and I'm going to divide the whole thing by 0.6. And that's going to give me the length of the other diagonals. So let me do that on my calculator. 9 divided by 0.6. It's going to be 15. And then 6 divided by 0.6 gives you 10. Again, I divided both of these things by 0.6 using that scale factor because it has a 3 to 5 ratio. And now what I've got is my two diagonals. And then the area is 135. And from there on out, you're working it the same way. The area of a kite is also 1/2 d1 d2. The area is 135. Equals 1/2 d1 d2. D1 and d2 are these two diagonals. So I'm going to set it up as the first diagonal is 9x minus 6. The second one is 15x minus 10. I would again move the 1/2 over by multiplying. Flip and multiply. That gives you 270 equals 9x minus 6 times 15x minus 10. Multiply, combine like terms, and then use my method just like we did on the last one.